When it comes to testing your code against something like DynamoDB, it can be a bit of a pain. This is because you have to push your code up to AWS every time you want to test it. Those CDK deploys can take 5, 10, 15, who knows how long, but they can take a while before they can deploy to AWS, which slows you down as a developer, meaning you have to wait longer and longer so you can test your changes. So what we're going to look at in this video is a way you can get around that by testing against a local DynamoDB version in a Docker container. What this allows you to do is write tests for your functions and your logic, have that hit your local DynamoDB database, make sure all your logic is sound and correct, then push that to AWS, and then you don't need to keep repeating that push just to test things, because it should work because you've tested everything locally. Let's jump in. So here we are inside my IDE, and you can see here that we have actually a very basic, just kind of TypeScript project set up here. We have Prettier and TypeScript installed, and then that's pretty much it, just a base TS config. So let's now go ahead and actually set up the things we're going to need for this tutorial. So of course we're going to need Docker. As mentioned, we're going to be running DynamoDB in Docker, so we'll need to configure that. We're also going to be using Vitest for running our tests and writing them in our application. And then we're going to be using a few other things like the AWS SDKs for creating tables and actually the logic we want to test against DynamoDB. And then finally, we're also going to be using Zod for some TypeScript stuff, just to make sure we have the correct types for the data we're sending and receiving. So let's just go and install all of the things we need first. So over here in my terminal, I'm just going to run a few commands to install everything. So let's start by installing Vitest, which can be done by just running that command to install as a dev dependency. And then to save me having to type out all of the SDKs, we're just going to install a couple of SDKs from AWS, one for the DynamoDB client, and then one for some library stuff, just to make it a bit easier to use it. And then Zod, as we mentioned. So then that's all of the kind of packages installed for this tutorial. So I can close that out now. And then you can see it's just updated in here. The next thing we're going to look at configuring is Docker. Now it's worth mentioning before we jump into this that you will need to have Docker installed and configured on your machine. So if you don't already have that, I highly recommend just going and installing the Docker desktop. I will throw it up on screen somewhere now, just so you can see what that looks like and download it. If you follow that installation, that'll configure everything for you. Then you can jump back into this tutorial and we can follow along from there. So once you have your Docker desktop installed and Docker's all running on your machine nice and well, you can jump back into this tutorial, and we're now going to set up Docker. So to do that, the first thing we want to do in our application is we need to create a new file, which is a Docker compose file, which we can do docker-compose.yml, and then just create that file. And then inside here, we're going to basically define the containers, the Docker containers that we want to run, which in our case will only be one, and that'll be for the DynamoDB database. So let me just drop this code in here to save me having to type out the YAML. And then let's just go through this. So the version you see here at the top, if you're not familiar, is just the version of the compose file we're going to be using. So we can kind of ignore that for this tutorial. And then under services here is the actual containers that we want to define. Again, as we mentioned, there's only going to be one. So here we have our testing database, which is the name that we've given it. So you'll see in a minute when we start our containers up, this will be the name that we use to reference it. Then we have the container name, which is just kind of inside of it and local. We don't need to worry about that for here, but I've just called it DynamoDB because that's what it's going to be running. Then image, this is where the image of the code you're basically going to be using. We won't dive into it too much here, but this is the image name that you need to use for the local DynamoDB, which is published from Amazon. You can see here. And then we just take the latest tag of it here. If there was a previous tag you wanted to use, you could switch this out for, version 1.1.1. whatever it might be. We're not interested in that. We're just interested in the latest one. So we grab that. Ports, this is obviously another Docker thing. So inside the container, you have ports, and then you have the ports on your machine. Not going to go into it too much here, but essentially what we're saying here is we're going to take port 8000 on our machine and pass that through to port 8000 in the container. That's pretty much it. We don't need to worry about it. You'll see it again later on when we put the testing URL in, but for now, let's just not worry about that. And then the command here is just the command which we pass to the Docker container when we start it up. In this case, this is the command that was given to us from the DynamoDB Docker page, saying this is what the command you need to run to start it up. So this command just starts up the database basically once we start the container. Cool, so that is our Docker Compose file setup. So from here with our Docker Compose file now kind of ready to go, the next step we're going to do is we're going to add a command into our package.json file. We don't actually need to add this command. If you don't want to, you can just run the Docker Compose command. But for a lot of people, especially if this is a shared project and people aren't familiar with Docker, it's handy to have the command in your package.json file, just so it's in a simple npm run rather than having to remember the Docker Compose command. So let's jump over to package.json. And then inside the scripts, let's just paste in the command. So you can see here we've added a new command, which is just start testing DB. And then what this does is it runs the command docker compose up testing DB. Now, as you remember from our docker compose file over here, docker testing DB was the name of the container or the name of the service in this file, which will actually run our database. So by putting docker compose up testing DB, it's saying when we run this command, start that container up. So with that command now added into our package.json file, let's now actually give that a test shot. Let's start up our Docker container. So to do that, let's jump over to a terminal and let's just run the command npm run start testing DB, the one we added. And then you can see here, it's ran the command docker compose up testing DB, which is what we put in the package.json. That's all well and good. And then under here, you can see the logs coming out from Docker basically, which is saying, here's the container which has been created, we're attaching to it. And then these are the logs of it starting up on port 8000, so and so. So that is our Docker compose file and our Docker container for DynamoDB now set up and configured. And we can jump into the more kind of interesting part of using Vitest to actually write tests against this. So now let's jump back over to our IDE and start configuring Vitest and actually writing tests for our DynamoDB database to be used in. So let's jump back over. And then the first thing we're going to do with our Vitest already installed is we're going to add in the test command into our package.json so we can easily just run npm run test and it'll run all of the tests for us. So to do that, we're going to add a new script, which is here. I'm just going to call it test. And then underneath here, we're just going to put it to the command Vitest. That is it. That's all we need to add for now. That is our test command added. So we're now finished with package.json basically, and we're now ready to actually start configuring Vitest. So the first thing we need to do is we need to create a new config file in the project, which is going to be vitest.config.ts. So let's create that quickly now. And then let's jump into that. So inside this file, we can then drop in the config we're going to be using with Vitest. So let's just drop that in. So here is our config. So you can see here, we actually bring in the define config function from Vitest. This just allows us to define a lot of base config basically. And you can see we leave a lot of it as the defaults. The only thing we really add in is this global setup file, which just points to a file which will contain two functions, a setup function and a teardown function, which as you might be able to guess from that, the setup function will run before the test to set things up, and then the teardown function will run at the end of all the tests to tear things down. So we'll jump into that next. So let's just save this file. And then as mentioned, the next thing I'm going to do is create our global setup file. So to do that, we're going to create a new directory in our project, which is the tests directory. Let's just create that like so. And then inside this test directory is where we're going to put our global setup. We're also going to write our test in there in a moment as well. So for the global setup, it's going to be global.setup.js. And then inside here, there's actually a fair amount going on in here. So let me just drop this in and then we can walk through everything that's going on in this file. Here is the config for the file. As you can see, there's quite a lot going on in here, but we will run through this now. So to start with, we bring in a lot of commands basically from the client DB SDK that we installed. This just allows us to create the tables, to delete tables. We'll go through all that now. So then the first thing we do here is we create a new DynamoDB client with, most importantly, this endpoint property specified, which points it to our local DynamoDB database. By default, this will try and reach out to AWS and it won't be able to get anywhere because we haven't deployed anything for that. So you can see here, we put it to localhost 8000. And if we remember back to our Docker compose file from earlier, the port 8000 on our machine actually connects through to port 8000 in the container that we made for DynamoDB. So that will then connect everything up. After this, we then define the table name that we want to use for our testing database. Here, I've just called it very creatively testDB. And then what we're actually going to do is we're going to skip over this poll tables list function because we'll see where that comes in a second. Same with poll table. So then this is where we have our setup and our teardown functions. And in our setup function, we actually have to create a table onto our DynamoDB database that's running in Docker. This is because even though we've started up the DynamoDB database, there's no tables on it for us to test against. It's just a completely empty database that's running. So we have to actually use the create table command here to create a new table on that database. So what we do here is we run that create table command, passing in our table name from earlier, which we looked at, which is just testDB. And then we define a couple of attributes. In this case, I've just done PK and SK for primary key and sort key, following the one table design philosophy that a lot of people do in the DynamoDB world. Both of these are just attribute types of strings. And then we set up our key schemas and our billing modes. Again, we just set these both to PK and SK with the key types of hash and range. And then the billing mode can be provisioned. I've just set it to pay per request for on-demand billing, which is what I tend to use. And then what we saw earlier with this poll table and poll table list functions, you might be wondering where they come in. So this is where one of those come in, the poll table. So what happens is the create table command will exit as soon as it's sent the command. It'll send the command to the database and the table will start getting created in the database, but this command will exit. So what we need to do is we need to actually wait for that table to be created and to be active and ready to go, because otherwise what will happen is we will send the create table command, the setup function will exit, the test will start running, but then the database table won't actually be ready and then the tests start failing. So what we need to do is we need to use this poll table function, which I've written, which will just allow us basically to continuously poll the database to check the status of it. So in this case, we take in our table name and then we pass that into the describe table command and we get the table back from the database and we check its status. If the status isn't what we want, which is active, then we rerun the poll table function and we just basically keep recursively calling it until it is active and then we exit. Once the table is active, we then exit the setup function and allow the tests to run because we know it will be ready for them to test against. And then that is our setup function. So now we can start looking at our teardown function, which as you can see here is very similar to our setup function, but instead of creating a table, we're actually deleting one. So in this case, we send the delete table command with our table name of testdb, and then we will wait for the table to actually be deleted, much in a similar way to what we did in the setup function where we create the table and then we wait for it to be active. This time we're deleting the table and then waiting for it to actually be deleted. So as you see here, we send the delete table command with the table name, and then we run a poll tables list function, which we jump up to that. So then in this poll tables list function, what we do is we list all of the tables that are currently in the database. We then check that list of table names to see if it includes our table name. If it does, we then recursively call the function again to keep checking it. But as soon as our table name isn't in the list of tables currently in the database, we then return from the function and then we exit from the teardown function and we know everything's finished, everything's been deleted, it's all been cleaned up nicely. And that is our global setup file. That was our setup and teardown functions. So now with our global setup file and our setup and teardown functions complete and ready to go, what we can now do is actually turn our attention to writing a test, finally. So what we're going to do is we're going to create a fictional create book test, which will basically run a create command into the DynamoDB database, and then we'll retrieve that book from the database to ensure it was actually created correctly. So what we're going to do is inside our test directory here, we're going to create a new directory called books. And then inside this, we're going to create a new test file called createbook.test.ts. Then we're going to open this up. So let me just drop the code in here quickly and then we can go through it all and we can see what's happening. So now I've dropped in the code for this test, you can see what's going on. So to start, we use Zod, as mentioned earlier, to define a schema for the data that we're storing in and out of the database. This is because DynamoDB doesn't have native TypeScript support for the data you're storing in and out. So we create our own schemas for that. What we then do is create a new DynamoDB client for our test to use here. And what we do is we define that endpoint to be localhost 8000 again, much the same way we did in the config and setup file a moment ago. What you'd probably do in a kind of production real world example is if this was used inside a test file that you were testing, you would probably conditionally switch this endpoint in and out depending on if you're running tests or not. But we're not going to do that in this video. Then we have our table name, which is the same table name that we created the database table for a moment ago in the setup file. Then after creating our DynamoDB client and the table name, we are then ready to actually jump into the testing blocks. So you can see here we have our describe block, which is create book. And then we have one inside of that called success. This is just how I tend to structure my tests. You don't need to structure it in this way. I tend to have one for success and then another one for errors just to try and keep it nice and organized. You don't need to do that. That's not a requirement of this video. Then after we get into our success block, we then have our one and only test for this video, which is create a book. So what we basically want to test here is that we will run a command or run a function, which will then create a book in our database, and then we can retrieve that book to then ensure that it was actually created. So what we do here is we run a put command using DynamoDB's SDK, just to create an item in the database, which is user free, book free, example author, example title. So then this will run to create a new book in our database. And then what we then do is we then retrieve the book from the database with them items. So using the user free and the book free, it will then retrieve that data from the database. We then pass that through Zod to make sure that it matches the schema that we've outlined here. So it has a PK and SK, an author and a title. And then finally, we then do an expect statement on it from Vitest to make sure that it matches the object here. So then all in all, what this is doing is it will create a new item in the database. We then retrieve that item from the database, and then we expect on that item which we retrieved from the database to ensure it matches the one that was created. Now, obviously, this is a very theoretical example here. What you would probably most likely do an example is have a function which runs, which then that function will create stuff in the database, and then you'll retrieve that separately in here. But to save us having to create a whole new function for that, we've just done this straight here, which would basically you'd be replaced with a function. So now with our test made, and we've actually now got everything written and ready to go, let's now run our tests. So what I'm going to do is I'm going to run mine using a NeoVim plugin, which I've got, which allows me to run Vitest tests. And as you can see here, it's just passed for us. Of course, you could then use VS Code to run it through your IDE if that's your IDE, or I'm sure there's other plugins for other IDEs out there. You can, of course, also run using the npm run test command that we run, which will then run all of the tests in the project, or you can just run the Vitest command in your CLI. Any of them will work and they will all run the tests. But as you can see here, most importantly, our test has now been created and everything's working fine in our project. And with our test now passing and everything working as expected, our tutorial is now finished. In this tutorial, we've looked at how we can build and run Vitest tests against a local DynamoDB database in a Docker container to save us having to push code repeatedly to AWS through the CDK to test if something works and having to wait 5, 10, 15, 20 minutes every time we deploy something. I hope you found this tutorial helpful, and if you'd like to see the full example code for this project that we've gone through, you can see it over on my GitHub. I will put it on screen now. In that repo, I've also included a few other example tests alongside the create book one that we've made in this video. So if you want to see some other inspiration of how to do other things like updating or getting or deleting, or also how to test errors, make sure to check it out in that repo. There's also a written blog post version of this tutorial, so make sure to check that out over my blog if you're interested in reading it a bit more in depth and copying and pasting all of the code snippets that I've used throughout this tutorial. Finally, if you want to see any of my other CDK tutorials, make sure to head over to the GitHub repo or check out any of the blog posts or YouTube videos that are linked from that repo as well to understand more and build more with the CDK. I hope you found this tutorial helpful, and if you want to see more web development and AWS videos like this, make sure to subscribe to the channel. And until next time, thanks for watching. Bye.